Hey guys, it is Eric again. Finally found a little bit of time before classes to attempt to record a video. Hopefully I'll get it all done, but no promises on that. Before we begin, I want to give credit where credit is due. The inspiration for this mod is by iChun. He made a Googly Eyes mod, and I'm going to be attempting to basically recreate exactly what that does. Yeah. Another thing real quick, if I have weird pauses, I'm going to try to cut it out, but knowing my editing skills so far in this series, I'll probably forget and it won't look good. But I'll try to put up a picture of what I'm doing. Basically, I'm in one of my classrooms before my class starts, and I just have my computer hooked up to the projector, so I'm at a really awkward angle trying to look at the projector, but also still have my computer connected to the projector and all that jazz. So yeah, pardon if there's just weird pauses of me thinking. I'm trying to look at the script and scroll and make sure I'm typing the right code and all that stuff. So yeah, first things first, in link in the video description, there's a texture you should download. It's called eyes.png, and you should put it in your client name assets directory. I've already done this, but make sure you do it or else your eyes will be pink and black, and you don't really want that. You want them to kind of look like eyes. Next thing, so first we're going to go into Net Minecraft Client Render, and we're going to go to GL State Manager. We're going to scroll all the way down to the end here, and I'm going to have in the description again 2 enums to paste in, and these are copied directly from 1.10.2, but they're just not in 1.8, and I use them because there's just a lot of numbers that I don't remember. So I'm just going to paste those in right here. Once again, you don't need to type these out. I'll leave them in the description. There's no point in you guys typing all this out. So yeah, and we're going to save that. Now we are going to create, let's go to our events, and we're going to create a new event, which is going to be called the World Unload event. As the name suggests, this is when the world unloads. So we're going to say extends event, and make sure, oops, gotta save. Let's make sure I import the right event of client name event. We're going to say private final world. Let's generate a constructor for it. Import world, and we're going to say we're going to just take in a world and say this dot world equals world, and control space get world. Yeah, so now we can get the world, and now we need to call this event. So it's going to be called in a few places, and so let's go to Net Minecraft, Net Minecraft, and then we want to go down to server. We want to go to Minecraft server, and we want to search for this function, delete world and stop server. And so right before we flush the world, we are going to say new world unload event and pass in world server. Now what we want to do is also search for the function stop server. And we want to look where we're flushing the world, and we're going to say new world unload event, pass in the world server. Now what we want to do is also find where we unload the world again. So we want to go to Net Minecraft client right here in Minecraft, and we're going to search for, funny enough, the function load world. And so we look for the load world function. Here we go. So what we want to say is if the world we're trying to load in, so we're going to go right up here. We're going to say if world client in does not equal null. So if we're trying to load a new world, we want to, oops, there needs to be an if there, doesn't there? We want to unload the world. So if there's a current load world in, we want to then load the new world, and we want to call new world load event, and we're passing the client world. So yeah, that's gonna be for that event. Now what we want to do is in our cosmetic controller that we created last time. So let's go to the cosmetics thing. We want to go to cosmetic controller. We're going to make public static boolean show render eyes. We're going to pass in the abstract client player, and just like the rest of them right now, we're going to return true so we can see if our cosmetic is working. But in the future, I will cover the whole server-side stuff of this, where you can give out cosmetics to people or whatever you want to do. Or you can make your own if you want. You don't have to use my stuff, but I eventually will cover it. Just haven't found a little bit of time yet. So now let's make a new package, because the Googly is going to have a lot more things in it. So we're going to say .eyes, and oh, someone's texting me. Okay, cool. Guess I'm meeting someone for lunch, so this is going to be a little bit short, but I'll do as much as I can right now. So, in the eyes, we are going to make a new model, eyes. And I'm going to say extends cosmetic model base. Add the constructor for the render player. And then I'm going to make two arrays here. So private model renderer irises, iris. Well, it's technically irises, but okay. Let's just call it iris. That's good enough. New model renderer. Making an array with 12 elements in it that we want. Private model renderer. And we want the pupils. Pupils is new model renderer of 6 elements. So now once again, there's going to be a lot of numbers here, which are numbers part of pi, and I'm going to put them in a link in the video description so you can copy them and just paste them right here. You don't want to spend your time typing out these numbers, I guarantee it. It just makes it easier for you guys to copy and paste at least these numbers. So, yeah, now that you got that in here, we're going to start making the model. So, let's see, just, I'm going to remember to cut this part out. I'm setting an alarm so I can meet someone for dinner, or for lunch. Cool. Okay, sorry about that. Back to the tutorial. Note to myself, cut that out. So we're going to say for int I equals 0, I is greater than iris.length, I plus plus, go through all the models, and I'm going to say this dot iris of I is new model renderer. We're going to pass in this, comma 0, comma 0. Going to say, oops, why is dot length? Oh, heck. Forgot a semicolon. We're going to say this dot iris of I dot set rotation point. We're just going to say 0, 0, 0 for the rotation point. And this iris of I dot add box we're going to say negative 0.5, negative 1.88, negative 1.0, or negative 1.0, 1, 3, 1, and then we're going to add another 1, which is 0. See, did I do that all right? I did not. Well, let's see, did I write those numbers right? 0.5, negative 1.8, negative 1, 1, 3, 1, 0. I have to do. Do I have to make these all floats here? Yeah, I do. Okay, so I guess I gotta put floats after all of them. That makes sense because they're not doubles. Okay, that's good for that one. And then we want to set all the rotation angles for the irises. So we're going to say this dot set rotation angles. Rotate. Okay, hold on. Rotation angle. We haven't made this yet. I don't want to import the other one. We're going to say iris of 0. And we're going to pass in 0.0f, 0.0f, and negative part of pi 1. So now I'm going to copy this, do 1, 2, 3, 4, 5, 6, and change that to 1, 2, 3, 4, 5, change that to negative 2, negative 3, negative 4, negative 5, negative 6. Then we can just copy this again, paste it here, remove all the negatives, but then we're going to go 5, 4, 3, 2, 1, and change this to be 6, 7, 8, 9, 10. So we got those. We haven't made this function yet, but we will make it in a second. So now what we want to do is go for int I equals 0. I is greater than pupils.length. I plus pupils. You can copy this up here really quick and just change it to pupils. We're going to say this dot pupils of I dot set rotation, or no, we want to add a box, don't we? Yeah, we want to add a box, and we are going to say negative 0.5f, negative 0.88f, negative 1.5f, 1, 1, 1, 0.0f. Hey, I did that correct the first time. Woohoo. So now what we're going to do is say this dot pupils of 0. Oh no, we want to do this dot set rotation angle. I cannot spell rotation angle of pupil PUPILs of 0. Going to say 0.0f, 0.0f, and then we're going to say negative POP of 2. Copy this, and we're going to paste this 5 times. Yeah, there we go. 1, 2, 3. Oh, I'm missing 1, 5. And we're going to change this to negative 4, negative 6. Oh, actually, you know what? I don't want 5. That's going to be problematic. I just miscounted in my head. And then this is going to be positive, positive, and this is going to be 4. Oops, 4. Okay, so now let's create this method. Set rotation angle. using it a lot, should create it. And so we're basically just going to say, let's just call this X, Y, and Z. And this is going to be called M, because it's short. We're going to say m.set, or no, not set. We're just going to say m dot, what was it, rotation? Yeah, rotation angle X equals X, m dot rotation angle Y is Y, m dot rotation angle Z is Z. This saves us having to put all those in here. So now what we want to do is actually start to render it. So we're going to override the render method, and we're going to make it do absolutely nothing, because we're going to write other things that render it, but we need to override this so we don't actually render anything. So I'm going to put a note to myself that just says, nothing here. So then I want a public void render iris. We're going to pass in a float of particle text, and we're going to go for int I equals 0, I is greater than iris dot length. Oops, length. I keep typing too fast while trying to like talk and look at the screen at the same time. This dot iris of I dot render of particle text. And so now we want to render the pupil, so we're going to say public void render pupil, P-U-P-I-L. We're going to say float X, float Y, float size. Oh, actually, no, we don't. That's going to be from move. Sorry, we're just going to pass on a float particle. I'm getting ahead of myself now. Sometimes when I scroll too far in my notes. So we can just copy this. And we're going to say pupil here. P-U, pupils, and pupils. Alright, then we want a public P-U, public void move pupil, P-U-P-I-L, float X, float Y, float size, so we can change the size of the pupil. And so let's make float shift factor to calculate depending on the size of it, how much we want to shift. So we're going to say 1.45 f minus the size times 0.525 f, and then we want to divide that by the size. Now I want to say equals. So then we have that, and then we want to say float for int I equals 0, I is greater than pupils, length, I plus plus. Go over the pupils, and then we want to say pupils of I dot rotation point X equals negative X times the shift factor, and we're going to say pupils of I dot rotation point Y is going to be equals negative Y times the shift factor. We also then want to times that. Let's cast to a float of math dot cosine of math dot 2 radians of X divided by 1. Then we want to times that by 90, I think. Did I do that right? I don't think I did that right. Let's see, hang on. Math of cosine. Oh, yeah, I need to put that in parentheses there. That would work. Okay, I was missing a parentheses there. So yeah, there's that for the model. Now I am going to start by creating kind of the little bit of a physics engine for it. We just want the eyes to move around like Googly Eyes would. So let's just call this eye physics. PHYSICS, eye physics. So I'm going to have a couple of things in here. We're going to say private final abstract client player, private final random, let's import random. We want to say private boolean should update. We'll just make that true at the beginning. Private long last update request. We want to no, it's not really a request update, it's probably just last update. That's a good enough name. And then we want a private double motion X, and then we want a Y and a Z, so we'll just copy, change that. And then we want public of a class we haven't made yet called IInfo eyes. So let's create the class called IInfo. And so we're going to say public class IInfo. We're just going to make it an internal class. And it's going to just have a few things. We're going to say private float rotation yaw, private float rotation pitch. We want public float previous delta x. We want a float, public float previous delta y. We want a public float delta x and a public float delta y. And then we also want a private float momentum x and a private float momentum y. This is going to get into a little bit of complex math stuff, but just hang out with me on updating all the eyes for physics. Yeah. So in the constructor for IInfo, we are going to say previous delta x and delta y, or sorry, previous delta y equals delta y, delta y, come on, computer, and we're going to set that to -1. Then we want a public void update int the I, so 0, 1. We want to pass in an I physics, which is going to be the physics. We're going to say double motion x, double motion y, double motion z. Okay, here's now where we get into kind of the complex math stuff, but try to get this all done. So we're going to say float previous rotation yaw equals rotation yaw. And then we want a previous rotation pitch equals rotation pitch. And then we want to say rotation yaw is physics dot player dot rotation pitch, or previous rotation pitch, sorry. Or wait a minute, no, rotation yaw. What am I thinking? I'm doing yaw, not pitch. Now I want to do pitch. Now we're going to say pitch. And we're going to say pitch. Then we're going to say this, we're going to say previous delta x equals delta x prev delta y. equals delta y. So now we're going to calculate the momentum that we should move at. So we're going to say float yaw difference is the rotation yaw minus the previous rotation yaw, and float pitch difference is rotation pitch minus previous rotation pitch. Then we want to say momentum x plus equals motion momentum y. I'm doing y first. Plus equals motion y times 1.5f plus motion x plus motion z. I'm going to make this bigger for you guys to see. Motion x plus motion times rand dot next Gaussian times 0.75f plus pitch difference divided by 45f plus yaw diff divided by 180f. Okay, there we go. I know it's a lot of math, but momentum x is going to be easier. So we're going to say momentum x minus equals motion x plus motion z times random dot next Gaussian times 0.4f plus yaw diff divided by 45. Okay, so now we need to calculate physics for the dice. We're going to say float momentum loss equals 0.9. We're going to say float new delta x is delta. Oops, why did I type z? That's supposed to be x is delta x plus momentum x float new delta y equals delta y plus momentum y. So now I call this stuff the more math that Eric hates, because currently I'm failing math, and yet, yeah, I just don't like math. But more math if new delta x is less than negative 1f, or new delta x is greater than 0. We want 1. Is greater than those, we're going to say float new momentum, which is going to be momentum x times minus momentum loss float random float equals 0.8 f plus rand dot next float times 0.2f. That should be pretty good. And we're going to say momentum x equals equals new mo times random float momentum y plus equals new momentum times random float times rand dot next float. If it's greater than 0.5, then it's going to be 1f, or it's going to be negative 1f. Okay, 1f statement down. We got more maths to go. We're going to say if new delta y is less than -1, or new delta y is greater than 1, we're going to basically do the exact same thing. So I'm going to copy this, and we're just going to say change that to y, and that should be it for that one. And then we're going to say else momentum y minus equals math helper dot clamp. Where's clamp float? We're gonna say 1.0 or just 1f plus delta y, and then the min is gonna be 0. The max is gonna be 0.1. Repeating 9f. So now we're done with those if statements. More math. Going to say momentum x times equals 0.95f delta x times equals 0.95f if math dot absolute value you want a float of momentum x is less than 0.03. You want to say momentum x equals 0. Now we're going to do the exact same for delta x. Okay, we're almost done with this portion of math. So we're going to say float max momentum equals 1.3f. We're going to say momentum. Oops, I forgot. Momentum. Oh, okay. Hold on just a second. I forgot I'm meeting someone for lunch. Okay. So let me quickly finish this up, and then I gotta pause the video. So we're going to say, momentum x equals math helper dot clamp float of momentum x, negative max momentum, and then max momentum. And then we want to do the same thing for momentum y, is we want to clamp that. Now we want to say delta x plus equals momentum y, or no, momentum x, and then delta y plus equals momentum y. And then now we also need to clamp these between -1 and 1, so we're going to say delta x equals math helper dot clamp float of delta x to 0. We want to do -1 to 1. And we are going to do the same thing for delta y. Okay, now that we have this, I am going to stop for now. And I'm gonna go have lunch with a friend, and then I will, I gotta actually charge my computer too a little bit. I will be back recording this at some point. For you, it'll just be a jump cut, but for me, it'll be probably a couple hours. So, yeah, guys, see you on the flip side. Alright guys, I am back. It's been a little bit of time between these two clips, but hopefully it should look seamless with the magic of editing if I can figure out how the heck to do that. So yeah, now that we've gotten done with this math, let's do, let's get this all working. Let's get the physics working. So I'm going to make a constructor. And yep, it's going to error saying there's final field, so we're going to say abstract client player. We're going to say this dot player equals player. And we need to give random, so we're going to say this dot random. Random equals new random. And we're going to pass in the seed as math.absolute value of player.hashcode. And then we're going to times that by, let's go like 8,134. Okay, good enough. Then we want to say this dot eyes equals new eye info of 2. Oops, there's not supposed to be that. And we're going to say for int I equals 0, I is greater than eyes.length, I plus plus. We're going to say this dot eyes of I equals new I info. And then we're going to call a function that we haven't made yet called update. But we're going to create that right now. And we're going to make this public. So we're going to say if not should update and not or not cosmetic controller dot should render eyes of the player. We're just going to return out of the update function. No need to call it. We're going to then say should update equals false. Motion x equals player dot position x minus player dot previous position x. And same for the y and the z, so we're going to say y, and then same for z. And then we're going to say for int I equals 0, I is less than i's dot length, I plus plus i's of I dot update I this motion x, motion y, motion z. Then we're going to do a public void require update. Should require update equals true. Last update equals player dot world object dot get world time. And then we want a get last update and get player. So that should be it for the iPhysics, but now we're going to make another class called Physics Manager. PHYSICS Manager. And this is going to manage what iPhysics relates to what player and figure out when to remove excess physics so we don't lag the game out entirely. So we're going to have a private weak cache map of abstract. Oops, I need to import weak cache map, right? Maybe not. Abstract client player. Why is that auto completing? iPhysics PHYSICX. We're going to call this PHYSICX. Physics list is new recache map of this. Control Shift O should import everything. Oops, I've got the A for abstract player. Make this bigger so you guys can see it. So we're going to have a private static physics manager instance equals null get instance, but we're going to say if instance equals null, instance equals new physics manager event, and then we want to register the event manager. So event manager dot registered list, or no, we want to say instance. Sorry, register the instance. Then we want a public physics get physics, and we're going to pass in the abstract client player. And we're going to say if not physics if the physics list does not contain the player, then we're going to add them. Physics list dot put player new physics player, and then we are going to return physics list dot get player. Then we want an onTick event, so public void onTick client tick event. Call it event. Now make sure we put the add event target up here. Event target to make sure the event's actually being called. We're going to say if Minecraft.get Minecraft.the world doesn't equal null, and not Minecraft.get Minecraft.is paused. Is game paused? Yeah. So if the game is not paused and we're in the world, we want to go through and iterate and update all the eyes. So we're going to say, we're going to make a new iterator, iterato, we're going to say iterator of map.entry. That's not what I wanted. Map.entry of abstract client player to iPhysics. It iterator equals physics list dot entry set dot iterator. And we're going to say while iterator dot has next map dot entry of abstract client player to iPhysics. I'll just call this E equals iterator dot next iPhysics EP equals E dot get value. If EP dot get player dot world object dot get world time minus EP dot get last update is greater than 3. Then iterator dot remove. So if we haven't updated in a little bit, we're just going to remove them. Basically, it's like the world's gone. So then we want to say EP dot update. Yeah, now we are going to do the world unload event. So we're going to say at event target public void on world unload world unload event. We're going to say same iterator and map thing, so we can just copy down to there. Let's put a thing around there. We're going to say if ep.getPlayer.worldObject equals event.getWorld iterator.remove. So if the world's unloaded, just remove them. Alright, that's done for the physics manager. So now we can actually start creating the cosmetic for the eye. So let's do Cosmetic Eyes. And we are going to say extends cosmetic base. Add the constructor for the renderer. And the unimplemented method to render it. So we are going to say we want a private final model eyes model. We're going to have a private static final resource location texture, which is the one we downloaded at the beginning of this video. This equals new resource location of client name / eyes.png. So we are referencing this image that is in the link in the video description. You can call it whatever you want, just make sure it's placed in the right location. And then we want to say private static final float array head joint sneak is new float array. So these are just these constants. So it's 0, -1 divided by 16, and then 0. We're going to copy that, paste it here again, is new float array, which is just going to be of 3, and we're not going to initialize it to anything. Going to say, just copy this, so we're going to say I offset equals new float array, and we are going to do 0f 4 divided by 16, and 4f divided by 16f, and then 4f divided by 16f. So you have to have the f's there, so then you get the decimal points, and it's not integer division. Then we want to say the iris color equals new float array, and I'm going to do 0.9f, 0.9f, 0.9f. I'm going to have another one, which is going to be the pupil color, P-U-P-I-L, pupil color. Oops, there's an extra space there, and that's supposed to be a lowercase o. So new float array, and I am just going to make it black. 0.0, 0.0, 0.0. And then we want another float, which is going to be the half interpupil, P-U-P-I-L-L, distance. It's not the best name, but it'll work. And this is going to be 2 divided by 16. And then we want the eye scale, which is going to be 0.75. and then we want model scale equals 0.0625. Now you can change all these if you would like, but for this can be for my video, these are what they're going to look like. But these are easy to change if you would like to. It's up to you. So we're going to say model equals new model eyes, pass in the player renderer. And then now we can start rendering the eyes. And so we're going to say if cosmetic controller dot should render eyes. If we're not going to render eyes, we're going to return. Then we're going to say eye physics physics equals physics manager dot get instance dot get physics of the player. And what I am going to do is hold on just a second. Then we want to say physics dot require update. Then we are going, here, let me make this big again so it's easier to see. And I'm going to say GL state manager dot enable depth, GL state manager dot depth mask, true. And I'm going to say for int I equals 0, I is less than 2, I plus plus, so for both i's. We're going to say GL state manager dot push matrix float array joint. We want to call a function that doesn't exist yet. We're going to say get sneak offset plus in the player particle ticks, and yeah, that's I think all I'm gonna need for that. And what did I spelled that right? Oh, wrong. Particle ticks. So let's create this function get sneak offset, and we are going to basically just say if player dot is sneaking, we are going to return the head joint sneak, else we're going to return head joint. Perfect. And we could also have some more stuff in here. If you're in a higher version with elytras or whatever, you can add for different player models where the eyes should be located. Now what we're going to do is do GL state manager dot translate to negative joint of 0, negative joint of 1, negative joint of 2. We're going to now rotate the player, so we're going to say GL, or rotate the eyes state manager dot rotate. We're going to make two functions, get head yaw, and we're going to pass in the player. We would also want to, I guess, pass in the particle ticks. Probably. Yeah, we want to pass in the particle ticks as well. Or yeah, particle ticks, whatever you want to call it. I keep saying particle. Partial. Yeah, whatever. Partial. Dyslexic here, you know. Can't read words anyway. Yeah, I gotta not say particle ticks because it's not what it is. Then we want to say 0.0f, sorry about that, Rand. 1.0f, 0.0. Oh, what? Nope, okay. We want 0.0, 1.0, and then we want 0.0. So I'm going to make one more, which is going to be get head pitch. Now we're going to just rotate on this one instead of that one. So now we can create these two functions. And those are basically going to call another function. So we're going to return interpolate rotation. And for the head pitch, we're going to do player dot previous rotation pitch. Player dot rotation pitch and the politics. And then for this one, we're going to say return interpolate rotation. For the yaw, it's going to be player dot prev rotation yaw head. Player dot rotation yaw head. The ticks minus this function again. Player dot prev render yaw offset. Player dot render yaw offset. And the partial ticks again. Partial ticks. Okay, now we can make this function, which I will just put above those. And in here, we're going to say float f equals, so this is going to be previous angle. This is going to be next angle. So we're going to say next angle minus previous angle while f is less than negative 180. F plus equals 360.0f. And then we're going to go the other way. So we're going to say, while f is greater than or equal to 180, we are going to f minus equals negative 360. Or no, not, sorry, minus, yeah, there's a negative there already. And then we're going to return previous angle, partial ticks, plus f. Okay, so there's that math done. Whew, okay. So now we got, once we've rotated it, we're going to say GL state manager.translate negative I offset of 0 plus if I equals 0, half distance colon negative half distance negative I offset of 1. Now this is going to be negative I offset of 2. Negative I offset of 2. Then we're going to say GL state manager dot scale of I scale, I scale, comma, I scale, comma, I scale times 0.5f. And then we're going to say Minecraft dot get Minecraft dot bind or dot get texture manager dot bind texture of the texture. And now we just got a little bit more math stuff to do to get this all to look right, and then we can like test this all out and make sure it all works fine. So we're going to say, hold on, let me just make a note in my notes of where I am. Okay, so we're going to say GL state GL state manager dot color. Oh no, not clear color, just dot color. And we're going to say iris color of 0 for red, iris color of 1 for green, iris color of 2 for blue. Then we're going to say model.render iris and pass in the model scale. Then we're going to say GL state manager. What we want to do, GL state manager dot color again for the pupil color of 0. And I'm just going to copy and paste instead of taking this all out. 1 and 2, just like the last one. And then we're going to say float pupil PUPIL scale equals, and we're making a new function, get pupil scale PUPIL scale of player ticks, and then the I probably want to, this time I'm gonna pass in the eye as well, and we're gonna make this function. For right now, I am going to just say return 1, but I'm gonna make a something note, so it just appears blue over here, so I see it. I have a special fun thing we can do for this. But let's finish writing the eyes first. So we're going to say GL state manager dot push matrix GL state manager dot scale pupil scale 0 model dot move pupil. Now time for some fun math. Ready for this? Okay, physics dot eyes of eye dot previous delta x plus parentheses physics dot eyes of eye dot previous delta x times ticks, and then for the y it's going to be the exact same thing. So we're going to put this on multiple lines. And this is going to be y, but we want to, wait a minute, hold on, I'm missing something here. Yes, we want to plus, hold on, I'm trying to do the math in my head for a minute. So we want to do this minus, yeah, my computer just froze there. Okay, so we want previous delta x. Let me think about how to do this. Hold on. Previous delta x plus the delta x. This should be delta y. This should be delta y. This should be delta y. So we got delta x plus previous delta x plus delta x minus previous delta x times particle ticks. Yes. Okay, and this is going to be pupil scale. That makes sense. Okay. I don't know why it took me so long to figure that out. Model.move pupil. Oh wait, we just did that. Oops. I want to render pupil. Render pupil. And this is going to be model scale. And we're going to say GL state manager. Pop matrix. Twice. GL state manager dot pop matrix. And then after all that, I'm going to say GL state manager dot color 1, 1, 1, 1. Oops. Okay, so now the only thing left to do, oh, you know what, actually, we also want to do one thing. We want to say should combine textures. Make sure to set that to true before I forget. I want to do something kind of cool. I want to make it so if you are wearing, like, if you have a potion effect. Oh, you know what, actually, hold on. I keep forgetting things. We need to translate this, sorry. GL state manager dot translate 0.0, 0.2, 0.0. Okay, I need to like write better notes to myself, or I should like edit this in or something. Okay. Sorry, I just talked to myself. Anyway, back to the pupil scale. What I think would be kind of cool is if you're having like, if you have a potion effect on, it'll make your eyes go all wonky. I don't know, kind of funny. You don't have to do this, but I'm going to. So I'm going to say if, kind of to kind of show what we can do with the eyes. So we're going to do player dot get active potion effects dot is empty. So if they have some kind of potion effect on them, we're going to say random. Oh, I need to, what did I call it? Random. Oh, did I not make a random in this class? I thought I did. I guess I did not. Look at that. I need to make a new random. Yeah. Private random is new random. So we're going to say rand.set seed. And we are going to set the seed to player dot or math dot hash code or no math dot abs of player dot hash code times 1,000. Sure, good enough. We're going to say if potion. We want yeah, you know what I want? Let's create. I'm kind of doing this on the fly right now. We want another int up here. Say private int array. Potion time equals new int of 2, 1 for each eye. So now we got potion time. So if potion time equals null. Or potion time dot length is less than 2. Potion time equals new int of 2. And then we want to say for int I equals 0, I is greater than potion time dot length I plus plus. Going to say potion time of I. Oh, is there already something called I? What is this? This is the I. Potion time dot I equals 20 plus rand dot next int, I don't know, like 20 again, I'll be fine. And then we're going to return 0.3f plus cast to float of math dot sign of math dot 2 radians of player dot ticks existed plus the partial tick divided by potion time of the I times 360 plus 1f divided by 2f. Wow, I got that right all at one time. Okay, cool. So now the last thing to do, we can't forget to do this, we have to go into Minecraft, net, Minecraft. Client. Sorry, my text were just distracting me. Net Minecraft render entity render player. Why am I blind? Render player. I found it. Okay, and we just need to add the cosmetic eyes. Okay. If everything goes right, we should be able to play and it should work fine. But if it doesn't work, I'm gonna have some debugging to do, and you guys won't see it. And yeah. Oh, my friends are trying to make plans to eat dinner. It's like 4 o'clock. I don't want to eat dinner now. Sorry, I'm ranting to you guys about my friends. Okay. Hopefully. We have some bugs. Okay. Well, I'll be back, I guess. And let y'all know how I fix my bugs. Alright. I have fixed one of my bugs. That is supposed to be a minus, and that is supposed to be a times. It's mostly working, except I don't have pupils, so I'll be back again once I look over my code and figure out what I did not type for my notes, because I can't do math on paper, seemingly. I can't do math in code sometimes, so I'll be back again, and hopefully this will all look seamless, like it just worked, and magic. I don't know. I'll figure out my editing later. Well, that didn't take long. I don't know why I typed a 0 here, but that's supposed to be a 1. If I scale by 0, you won't see it. But it works now. We have Googly Eyes that move around with you. Why you'd want this, I don't know, but there you go. And if we give ourselves a potion effect, we'll do like speed for 10 seconds. You'll see my eyes go all wonky because I have potion effects. I know. But yeah, guys. This is the end of the tutorial. I have to figure out a better way of, like, if I find errors to edit them out. But like, I'm only human. I'm doing my best, guys. Yeah. I'll see you guys in the next one. Hopefully it's like a lot better than this one, because this one was like recorded over multiple hours of yeah. Anyway, this is my long-winded way of saying thanks for watching, my dudes. See you in the next one.